Welcome to Geometry Pre-AP at Westside High School, the greatest class in the world. Today we're going to learn about finding the areas of trapezoid, rhombi, and kites. Some people say rhombuses instead of kite or rhombi, but I'm going to use the word rhombi. I like it, it's better. So first, a little information for you. The height of a trapezoid is the perpendicular distance between its bases. So what we have here is we have the height, which is this perpendicular piece between the bases. Now, that's not always in the picture. Sometimes you have to draw it in, like in this case over here, there's not one on this side of it, so we could draw one in here too. Also, remember, we have a nice rectangle that occurs inside here of the triangle. So that can help us sometimes move our numbers around that we need. And of course, we also have diagonals of kites and rhombus. Let me remind you about the diagonals of a kite, that they are perpendicular, and this one is bisected. And then in a rhombus, that these are perpendicular, and these are all bisected. That will help us when we do our area formulas and stuff like that. Okay, so we go to our next slide here. So the area of a trapezoid is 1/2 the height times the sum of the bases, base 1 plus base 2. And that the area of a rhombus and a kite is actually the same formula. It's 1/2 diagonal 1 times diagonal 2. Remember that you need the whole entire diagonal, not just the parts. I do see some people who mess up. This is not 1/2 diagonal 1 and 1/2 diagonal 2, but you multiply the two diagonals together and then take half of that product. All right, and so we're going to get into the work here right away. Remember that you are to do the problems with a star, and that I'm going to do the problems that don't have a star. So our first problem for today here, I'm going to work this one. We need to move some information around. So if this 5 is located on this side, and this is a parallelogram, we've got a 5 right here also, a 5 and a 5 and a 5, and this 4, and we get this 4 here, here, and here. So by labeling those numbers in the right places, we can see information. Now we do not know that piece right there. And so we have this blue parallelogram. We learned how to do parallelograms last time we were in class. And then I have this nice big red rhombus because the sides are all congruent, and that makes it a rhombus. So I need that missing value there. And if you remember, we have a Pythagorean triple that's blank 4, 5. And so that missing value there is a 3 in 3, 4, 5. If you didn't remember that, you could go in and do Pythagorean theorem and get that value. But we want you to know those Pythagorean triples. So when you're doing area problems, we always want you to write the formula. So the area of the parallelogram is base times height plus the area of the rhombus, which is 1/2 diagonal 1, diagonal 2. We want you to write that formula every time because, remember, you have to memorize those formulas, and we want you to have practice writing those. So my base in that parallelogram is going to be the 4. This is where it becomes tricky. There's no height inside the parallelogram, but this perpendicular segment here in blue that I just lined up is the height of the parallelogram. It's not inside the figure, but it is on the outside. It still represents the distance from the top part of the parallelogram to the base. So that will be 3 plus 1/2, our first diagonal. The short one there is 6, 3 plus 3. And then the other diagonal is 4 plus 4, which is 8. And so then I get 12 plus, that's 48 divided by 2, which is 24. And so my answer here is 36 units squared. Now I'm going to want you to do this other problem over here. Notice that this is a trapezoid and a rectangle. And so you want to write your formula out. When you're done working this problem, I'm going to put the area answer here, but you're going to need to work to get credit for it. So the answer for the area for that problem is 67. So make sure you keep working until you get that answer. So pause your video, do that starred problem, and then start the video again. Okay, so now we go on to the next page here. Some of our shapes will be shaded and have white areas here, and so we need to be able to learn how to interpret and see it. And so when we see a shape like that, we have the total shape here, which is a parallelogram, and then the white part is actually a kite. So if we take the parallelogram and subtract the kite area, we end up with what's our total area left, which is what we want. So let's write our formulas. We got big B, or little b times h, base times height, minus the diagonal 1/2 diagonal 1 times diagonal 2 for the kite. And so this is the total area of our shape. So if I go in here, the base of this parallelogram is 12. The height, which is over here to the side, is a 7. So that's the area of the parallelogram. We got to subtract the area of the kite, so that's 1/2. Now this diagonal right here in blue is the same as the sides. It's like a whole big parallelogram here. So that's going to be 12. And the diagonal for that parallelogram, this one right here, remember these are all right angles. So we need this value right here. That's the same height as it is out there. So it's a 7. And so when we multiply this, we get 84 minus 1/2 of 84, which is 42. And so our final total area here is 42 units squared. So learn to interpret the figures, look for the shaded areas and stuff like that. Don't try to do this as 3 separate little triangles. That's going to be a nightmare. I don't even think you can find the values of any of the triangles that are in there. So look for large shapes minus shapes that you can work with. Okay, so we go to our next page here. So there's a starred one for you to do, and then there's one over here that I'm going to do. When you have a problem and you see a 60-degree angle, we need to look for 45, 45, 90s, and 30, 60, 90s. And so when you have those, or Pythagorean theorem occurring, when you have those types of problems in there, your answer is going to be exact. We don't want a decimal. That only comes when we're using trig in these problems. So if this 5 here represents my short leg, then my long leg is going to be that short leg times the square root of 3. So this is 5 square root of 3. We need that height there because this is a trapezoid. So we start off with our formula. Area is equal to 1/2 height times base 1 plus base 2. I go and pull my information out of there. So area is equal to 1/2. My height is 5 square root of 3. Oh, Lord's doing some crazy things here right now. Times base 1, which is 13, that's the top, plus base 2, which is going to be the 20. Once I have that, I start working through my problem. So that's 1/2 5 square root of 3 times 33. Now I can't really take half of any of these numbers, so I'm going to multiply these numbers together. And when we do that, I'm going to get 165 square root of 3 all over 2. And I'm just going to leave that as an improper fraction. We have a unit this time, so don't forget your unit squared. Okay, so what I want you to do is I want you to pause the video. I want you to do this starred problem on this page. Let me remind you that there is a 30-degree angle here and that the diagonals are all perpendicular, so let's remember that information. And pause the video, work the problem. The answer for this problem is 64 square root of 3. So you need to make sure you have work to show and prove that you worked out this problem. All right, so now that we've done this problem, we go on to our next page here. You're going to be doing this problem here on the left side. I'm going to go over this problem here on the right side. Now, the first thing I want to notice here is that's a 40-degree angle, so that means I'm not going to be having an exact answer. That means I'm going to have to use trig in this problem. All right, so that's important to recognize that. And so I need, this is a kite, you can tell by the sides, okay? And we know this is a right angle, got to have right angles to use trig. And so I need this value here, but I really need the whole entire diagonal. So I'm going to have to double that value. So diagonal 1 is easy to see. That's 8 plus 16, which is 24. Diagonal 2, that's going to be 2 times the value of x when I find it. So if I'm finding the value of x, this is my opposite. This is my adjacent for the 40-degree angle. So that means I'm going to be using the tangent of 40 degrees equals opposite, which is x, over adjacent, which is 16. So x is equal to 16 tangent of 40 degrees. But I need the diagonal 2, which is 2x, which means 2 times 16 tangent of 40 degrees. When I simplify that, I'm going to get 32 tangent of 40 degrees. So when I go to work this problem, again, I want to write my formula. So 1/2 diagonal 1 times diagonal 2, 1/2 24 times 32 tangent of 40 degrees. All right, once I've got that, I'm going to simplify my problem here. The 12 and the 24 will give me 12 times 32 tangent of 40 degrees. I think it's now time to put that in the calculator. Once I put that 12 times the tangent of 42 degrees in my calculator, I'll get 322.8 2143, and of course my units squared. All right. So you have a trig in this problem, you're going to have an answer rounded to however many decimal places it says. Since it didn't tell me, I'm going to round to my standard 4 decimal places, which is the 10,000ths. Now, here's this problem over here. Let me give you a hint. If I see this first triangle up here, that triangle right there, triangle A, I've got two sides. I'm going to use Pythagorean theorem there, which means I'm going to have an exact answer because I also see that 45-degree angle. So this is a trapezoid here. So remember your work here. This is one that you're supposed to work. Pause the video, work this problem. When you turn the video back on, I'll put the answer up here so that you can at least check what your work, but you're not going to get credit for doing the work if you don't have some effort that goes with that answer. So pause the video now and then turn it back on when you're ready to look at the answer. All right, just to give you that answer so that you'll be able to check later on, this is going to be 756 plus 819 square root of 2 all over 2. So we can't combine these like terms. They're not like terms, but you need to make sure you get that answer. There's two different areas here, and one of them has a radical in it, so we're not going to be able to combine those like terms. So make sure you come out with that answer. If not, we'll put you into a separate group during the notes when we get to class to go over that. All right, so this is a problem that I want you to do. So it has a star by it. Notice the 42 degrees in there. You're going to have trig in there. You're missing the height. You need to find that before you can do the area of the trapezoid. So pause the video, work this problem, turn the video on when you're ready to check your answer. All right, since you had to work this problem, and it does have trig in it, you're going to have a decimal answer. So your decimal answer should be 444.1626 units squared. So make sure you got that answer, you have all your work out, write your formulas out, and work through that problem. Got to have work to get credit for having attempted that problem. All right, so this problem I'm doing for you, I didn't put a star by it. If you wanted to pause the video and try to work this one yourself, you could, and then you could see if you got it right or not. Okay, so this is a kite. I guess I should have marked that information in there. All right, and so we have this kite, and we got to find the areas. Since I have a 30-degree angle, right angles, and 45 degrees, this is going to be an exact answer. Okay, so in this one, I got two diagonals. I got diagonal 1 and diagonal 2. One diagonal I know already, because if this is 4 meters, this has got to be 4 meters. So one diagonal is 8 meters. The other diagonal I don't know. I'm going to have to spend some time solving that. So this is a 30-60-90 triangle, the red one here. I need to find the long leg, which is here, which is going to be the short leg times the square root of 3. So this is 4 square root of 3. Over here in this green triangle, this is a 45, 45, 90. So I know that's 4, so this is 4. Don't need the outside edges. I'm not asking for perimeter for this figure. We're doing area now. So if I look at this, the new diagonal here, this part in blue, is going to be 4 plus 4 square root of 3. We can't combine those terms together, so we have to leave them separate. So area equals diagonal 1 times diagonal 2. Area equals 8. Oops, sorry, I forgot the 1/2 in there. So I almost made a mistake there myself. So 1/2, diagonal 1 is 8, diagonal 2 is 4 plus 4 square root of 3. Now, we cannot combine those two terms, the 4 plus 4 square root of 3. They're not like terms. So let's simplify what we can. We can simplify the 1/2 and the 8, and that gives me 4 times 4 plus 4 square root of 3. And so I can't add those things together inside the parentheses, but I can distribute that 4. And so I end up with 16 plus 16 square root of 3. This is my area. We're going to put meters squared at the end, and that is the area, exact area for this one. It's a special right triangle problem embedded in that area of the kite, so exact answers. This marks the last question, so you can stop your video, finish your problems, go back and watch it again, and have those questions ready to turn in on class on Monday. Have a great weekend.